Thank you. So it's not a talk exactly about GHDL, but more about how GHDL could be seen inside the open source EDA ecosystem. So you have a lot of many talks about ecosystem today. Okay, so quickly, GHDL started as a simulator. It supports most of the standard, at least until 28. There is a plan to support 2019 once 28 is completely supported. It's a compiled simulator, so it generates at the end object code, and the structure of it is made to support multiple backends. So you can see GHDL as a GCC frontend, like C++ or there is also Go frontend or whatever, Fortran. There is no intermediate generation of C code. It can also be used with LLVM, and there's also an internal code generator named mcode, which has the advantage of being very fast in generating, I would say, rather good object code. It's quite fast, at least to do the code generation, but the speed of simulation is not that fast, in particular if you use a lot of signals. I hope we have good error messages, and I hope we fix bugs quicker than the industry. Not sure, but probably. It's a full command line tool, so there's no graphical user interface. And in order to debug your circuit, you can use GTK Wave, which is also a famous waveform GUI. And to do that, you can either generate a VCD output, which is slow and large, or we can also generate a specific format designed for GHDL and GTK Wave, named .ghw file format, which is a little bit more compact and more powerful. Because it generates code, you can do some debug of your model using GDB, but it's a little bit not completely nice. Because it can use GCC as a backend, you can do some coverage with JCOV. That's something also to be improved. And it supports most of at least of the open source verification framework like UVM or OSVVM. To open doors, what we'd like to have in the future is to be able to do mixed language simulation. So right now, if you want to simulate both Verilog and VHDL or system Verilog designs, you cannot do that easily, and I think this is a real missing piece in at least for the VHDL world. Even for Verilog, there is no, I would say, easy to use IDE. That's also something that need to be done to be able to easily debug, to easily view your output without something a little bit more interactive than GTK Wave. In a different sector, I think there is also, I have never seen any implementation of tool to be able to do design with graphical blocks, like it's possible with Vivado. Maybe Python is a better solution, maybe not always, I'm not sure, to be something to be discussed. There is also the topic of schematic viewer, so we want something to be better than GraphViz, something more interactive, more easy to reproduce, to investigate. I think this is also a missing piece in the open source ecosystem. Okay, it's not very fun as a project, but that's something it could do also useful. And for the system Verilog landscape, I think there is no open source simulator that can support UVM, which is a graal of verification, at least in the industry. But I have heard of some work in progress in this area. There is this GHDL language server, which provide language server for GHDL, and so the integration with Emacs or VS Code or whatever, it allows to do. Well, it's quite good to do navigation, and there is some support of reformatting and insertion. I would say, okay, I am maybe not the only user, but one of the few users, and it quite improves the productivity because when you start the simulation, there will be no syntax error. It will, ideally, it always work immediately. Another thing I think it would be nice to discuss, maybe for people outside of the FOSS EDA community, is why do we want to have open source EDA tools? One of the issues with, at least with simulator and maybe also with synthesizer, that okay, Xilinx or Altera, Intel, they offer at least free version for small FPGA, and they are a very competitor for open source tools, at least for the maker community, which are still a large community. Okay, so we don't want to target exactly this community. Maybe it's a bit too hard initially. What we'd like maybe to target is also the industry, and it's okay. It's a bit like open road. Open source tool allow industry to make some tries, some experiment with a tool without investing a lot of money. The other possibility is this no license restriction, so you can run many instances of any open source tool at the same time, which allow you to do a lot of verification or a lot of state exploration. Recently, well, maybe a few years ago, I added synthesis support for GHDL. What we have to understand that it's only generate a netlist which is completely unoptimized, and generate either GHDL or Verilog netlist, and then it is integrated with GeoSys in order to do optimization of this netlist. An interesting aspect of it is that there is support of PSL, both for simulation and for synthesis, which allow you to do some formal verification using SimGeoSys, which is quite interesting, except that PSL is not what they use compared to system Verilog assertion. Okay, so again, we'd like to also to support multi-language for synthesis. There is currently incomplete support with GeoSys because you can instantiate in VHDL Verilog design, but there is a limited support for parameters of generics. It would be also nice to be able to support cross-module probing for doing debugging, real-time debugging. And it might also be interesting to be able to do cross-language type definition, so you can more easily mix structure or records defined in one language with another language. Finally, I have a rant about vendors. Maybe there are some here, I don't know. We all know that they are a heavy user of open source software. For example, many IDE are based on Eclipse. There are users of LLVM or GCC. TCL, of course, is a de facto script for EDA. A lot of Linux is used everywhere. Unfortunately, okay, they somewhat contribute back to this project, but it would be very nice if they were also more open in their format, in their bitstream, and for simulation, if they don't encrypt everything, because okay, we don't have the key, and so we are a little bit limited in what we can support with simulation for the FPGA. At the end, we can say that there is a long story of open source in the EDA. It starts back at least from SPICE, who everyone knows. It's still continuing in many directions, in many universities, and in many also communities outside universities. I think there is some still missing tools, like I said before. In particular, IDE, it would be something that would be. It's not a very fun project, but I think it's something that is also needed. And again, I think that still EDA vendors should be more open, if only they were. Thank you. Thank you.
So it seems this is the perfect talk for ending this workshop.
Thank you.
Good messages and a lot of to-dos to attract young persons that want to get involved into field open source EDA development. So, are there any questions?
No.
Many questions.
So you mentioned briefly mixed language synthesis. Have you looked into the USS RPC framework that lets it call a front end with a set of parameters?
Yes, no. The point that I want to do. I not only want to do multi-language synthesis, I also want to support multi-language simulation. So in that case, this is a bit out of this equation. And I also want to have the possibility of mixing types definition in language, which also make it a bit difficult with this. So yes, I am aware of that, but I don't plan to use it at least in long term.
First of all, thank you for GHDL. About 5 years ago, I had suddenly started using GHDL and it kind of saved my life.
Okay.
Not having an open source compiler was almost dead. And I want to say that I've used one of the users of your US's GHDL plugin. I've successfully managed to simulate a large chunk of GHDL on the regulator side. I would say not a small design. So, it's of course the number of signals that you get are enormous sometimes, but to a certain extent it's simulatable. And I'm just curious to know, because you listed so many things to do, I would like to hear more from you about your priorities on that. because everything seems like this could be nice, it would be nice.
Well, the priority form.
No, as like, what would you like to see be done first? And if so, actually, just to have an idea of what you're thinking.
No, okay. What I plan to work on is mixed language.
No. Sure, yes, we would like to hear that. Also,
Okay, well, yeah, what I'd like to work on is mixed language simulation. What I'd like to see, I think I will be very, very happy to have a schematic viewer. Okay, there's a lot of research about...
HDL schematic viewer.
Yes. Because, okay, if you do some design and you need to understand why there is a problem with your design, you often need to use schematic viewer. But that's one way to work.
So I saw some hands rising. Thank you, Tristan, for your talk. Thank you very much for your GHDL and your involvement in the project. So I am from Sorbonne University and we use a lot GHDL. So I may add an answer to the question why doing a FOSS tool. At university, it's really an advantage, a huge advantage, to teach students with the FOSS tools, because we are able to explain the algorithms in deep. We are able to show them that they can interact with the tool, they can add something, they can improve or degrade sometimes, but they can act on the tool. It's not a black box. And even for companies, EDA vendors, they like students who were taught with the FOSS EDA tools, because they learn the insight of the tools, not just clicking on buttons and things like that. So I think this is why EDA vendors also should become more open, because it's really an advantage for them to have university teaching students with the FOSS EDA tools. And also at university, we sometimes we have advices to learn students with company tools, because in industry they will be using those tools. But as I said, knowing the insight and understanding the tool in depth is better than just knowing the graphical interface. Also, at university, we don't have, we have licenses at a good price for the EDA company tools, but we don't have access to hotlines. Whether with the FOSS EDA tools, the students can interact on the web, on social network, and interact with other designers or designers of tools. Exchanges ideas, and everyone is looking for students in VLC design, in the EDA tools. Everyone wants to hire more people. So if we don't give students exciting things to do, they will not go. They will all go to other things. I don't want to mention them, but maybe we can discuss that after. Thank you very much.
Okay. Yeah.
Thank you.
Right, just to comment a little bit, at least on the support part, I think it's true that maybe you can find a lot of information about open source tools on the web, and a lot of discussion. It's also always surprising to me that when if there is some bug and can quickly fix, I can do it in a few days, no problem. And often people are very surprised of the speed compared to the industry. No comment.
Cool. Francesca?
It's a great project, and thank you, and also many other users. So I'm the overall hog, I don't know if you, and we plan to support GHDL in the future. And especially the thing you said about using it in CPCI. CERN now it's a big problem because you run simulation and they all the licenses very quickly. But what's the current or the plan to support IPs, the science IPs and those kind of things? Is there no way to...
No, there is no plan. I think during the ISC period, most of the IPs were completely open when it was VHDL or most of the time it was both VHDL and Verilog, and VHDL could handle them without any issue. And nowadays with Vivado, it's more and more encrypted. And okay, what can we do except if we want to stay legal, what can we do? I don't have any.
There is no channel of communication open between you and Xilinx, or they don't care at all.
No, Xilinx provides their own simulator, so I don't see any way I could try to convince them to open it a bit more.
Because it works with Quest or those things, so there must be an agreement.
Yeah, sure. They have an agreement. They have an agreement with Questa, well, with the vendors, but not with any open source tool.
There's another question from Robert.
So it's more just about the Xilinx thing. I think it is something that if people have contacts at Xilinx, then it's definitely worth pushing on, because we did previously get them to relicense the unencrypted primitives, or a set of the unencrypted primitives, as I think it was Apache 2 instead of a commercial license. So it is possible to get them to budge on things. It just requires small steps. So it's probably not something that should be written off altogether. It won't happen overnight, but yeah, if people know how to put Xilinx, then yeah.
Well, we can just hope for the best.
Yeah, great that you said, great that you said that, because I was going to comment on the could and should, and it would be nice. There is hope for the best, but plan for the worst. And there's also the serenity prayer, which says, God grant you the wisdom to change the things that you can, accept what you cannot change, and the wisdom to know the difference. And there's also, what is the best alternative in any negotiation or discussion? If there is no compelling reason for a highly consolidated duopoly or triopoly to link or to change things, it won't change. We are in a very mature semiconductor industry. So I think this is why, whether it's in, Antonino's special session at ICCAD about the mixed, open, and proprietary EDA commons. Why do we have these sorts of discussions? Is because really the situation is quite static, and the only community that can move, or hopefully will be willing to move, is the open source EDA community. It's not going to be the incumbents. So I just want to highlight that it was, we can all be hopeful, but the reality is we don't have time, and we don't have people. So what are we going to do differently? For example, will people converge on design drivers, or benchmarks, or interoperability, or shared engines, or is there any such outcome of this workshop that was envisioned? I understand we all learn a lot about each other and what's out there, but concretely, between this year and next year, what structurally will change in the FOSS community would be my question.
Okay. Thank you, and thank you to Tristan.
Any more comments or questions? Okay.
No response. Like,
Ah.
nobody's going to raise their hand and say, I want to donate this or I commit to do this. I'm sorry if I sound.
You want an immediate answer. You'd like to have an immediate answer.
Yeah,
Yeah.
because that's what we do. I mean, somebody says, I'm going to open source this bench, or I'm going to develop this vertical benchmark. I'm going to, provide a test bench for this so we can do, calibrated power calculation and dynamic power calculation, vectorless, vector. I mean, there's so much stuff. SI, CCS. I mean, in the ASIC world, of course.
Mhm.
But it's a huge list, and who's going to help drive this or create the building blocks? We kind of stay under the lamppost, if you know that old joke. Looking under the lamppost where the light is better. But there's a lot of other parts that are not very illuminated that still need to be handled. Deafening silence, I understand, sorry.
Everybody's expecting you to do these.
We try with a very finite resource.
I know.
And having tried this, just wondering, can we put more wood behind fewer arrows? It doesn't have to be, it could be a fork of the road, it could be anything, but.
I appreciate the more wood behind fewer arrows. It mentioned excitement earlier. One mechanism is to try to attract more young people, right, undergraduates and classes and competition and stuff. Try to build excitement, and that's what will get them more wood. And the fewer arrows, I guess what I would say is that it's very hard to discourage people from working on their pet projects, but encouraging more interoperability so that you can share code. Even if you're not sharing the name and sharing the top level organization, if there are more libraries that can be intertwined, more file formats that can be shared, right, ways to interoperate so that the community can mix and match according to their needs, and the winners and losers can perhaps be made more obvious.
So I think one aspect is what are you willing to contribute, and another aspect is what you like. And I think in terms of what we would like, what we would contribute, by we, I mean the community works like to spectrum pipeline. I don't have any very specific other than just continuous improvement of the open source tool that's available already out there. In terms of what I want, actually, I do have some very specific needs, and I don't know how to get it, right? And because I use FPGA on a daily basis, and there are two top-level pain points for me, neither of which are directly addressed by many of the research labs. The first pain point is not about performance at all. It's about the design cycle speed. The fact that you have to wait for so long every time you make the slightest change to your design. Now, I understand that it's a difficult problem in general, but I have a lot of structural information I have available to me as the source code that is being completely thrown away in trying to resynthesize and re-PNR from scratch every time. I have modular structure, etc., where it seems to me that it ought to be feasible to do an incremental change in one part of the FPGA without touching the rest of the FPGA, and hopefully the design cycle will greatly speed up there. So that's something I really would like to see in anybody's tools to be able to iterate much faster. And it's not just me, I think there are thousands of FPGA programmers, and all their man hours are being wasted on the same problem, on this problem. And it's not about best clock rate, it's not about best area, etc. It's outside. I think best clock rate and best area is the light under the lamppost, and the column is a little bit off to the side, outside the lamppost. The second problem I have is a little more mundane, probably easier to solve. It's simply a naming problem, which is that the timing reports that I get from FPGA tools make it difficult for me to relate it back to where the issue is, in the source code. That's a small, much smaller, but more mundane, but also equally useful problem. Because, and I say why the timing is difficult, as really why say, again, and maybe because I'm an IT user, it's because the names chosen on the path are often on FPGA fabric terminology. This pin of that lot, etc., on which I have no interest. I want to know in my RTL where was it. And sometimes the naming, because of the chance choice of choosing one name, which might connect to many different points in the net, it's the wrong name for the path that I want. Right? So it's a little bit of a name problem, and that's one thing on my list. Those are the two big things on my list.
You're using the model.
Yes, I'm using the model.
Just a comment, what Intel calls interactive RTL, it's a problem for ASIC folks as well, where they want 15-hour SPNR to become 10 minutes. And this has been a challenge from almost every company on private in the ASIC world as well. And so, the Road, for example, has RIP, and Antwerp has incremental global placement, where you swap in different subnetworks and fix up what you had before. It's far from ready to show anyone, but yeah, we understand this is a huge problem. And maybe, since there's electrostatic placers, in view for the FPGA toolchain, the same code even could be used. As a comment. And about naming in, again, the ASIC world, the report formats and the names are actually copyrighted. And so there is a constructive Tower of Babel in the commercial EDA world. You look at, I think, our announcement in 2019, we actually published safe naming conventions in Open Road that were directly given to us by a company that had survived a lawsuit from a bigger EDA company, and they had to clean up their names. And so, even by construction, we have to adopt safe names and safe timing reports. We can't actually match any existing timing report in your own timer, otherwise you can sue. So we have this kind of problem, and again, that's where one road bed instead of 5 road beds, or one, this is how we report a timing path with up arrows or down arrows or R's and F's, or with this column to the left of that column. All we need is one common way of doing it, and that will help a lot in my country.
Thank you very much. Tristan.
Okay, thank you.